Welcome to Section 2, Abstracting Language Constructs with Higher-Order Functions. In this section, we'll be learning about higher-order functions. They're useful to use in any project. There's a great chance you've encountered some variants of higher-order functions in your own programs. Throughout this section, we'll be learning how to promote reusability by using higher-order functions. They're great for doing work that is often repeated or requires a bit of setup. We'll look at loops. They're all over our code bases, and we'll learn how higher-order functions can replace loops in a far more concise and expressive way. Map and filter are two of the three most well-known higher-order functions, and have been a part of the language since ECMAScript 5.1. We'll create our own versions of map and filter to get a better idea of how the two functions work, and also because we might just be able to create better versions for use in our functional programs. You'll meet the reduce function, a third very well-known higher-order function. Reduce can be more complex to learn than map and filter. However, it has far more uses as well, so it's time well spent. And finally, it's almost time for us to start building an app using functional techniques. What better first step than by taking what we've learned so far and building higher order functions that render elements into the DOM. It's going to be a really fun section. Welcome to Section 2, Video 1, Promoting Reusability with Higher Order Functions. In this video, we'll be learning what higher order functions are. Remember when we learned about pure functions, there were lots of rules and guidelines? Well, higher order functions don't have tons of rules and guidelines, but they're interesting and have unlimited potential. We'll discuss the idea of writing generic functions. The more specific a function is, the less situations it will become useful in, and the more difficult they become to change in the future without breaking anything. Chances are you may already understand closures if you've been using JavaScript or another language that supports them. We will review closures in this video because they are important to understand from here on out. We'll wrap up by refactoring a configurable logging function into a more generalized and configurable higher order function. A higher order function is a function that either takes a function as input or a function that returns another function as its output, or both. The JavaScript language supports functions as first-class objects. That means we can use a function anywhere we can use any other value. And that is what allows us to create higher order functions. Otherwise, we couldn't pass functions as arguments to functions or possibly even return functions from other functions. Take a look at the kiss function. It takes any value as input, that's what the A represents, and when we kiss some input, it's either going to have no effect and we'll get back the same value passed in, or if the input was a frog, then it's going to turn into a prince. Below kiss is a function called transform. And it's a higher order function because it is taking a function as input. We're calling transform twice. We could pass values to the kiss function ourselves, but we prefer coding at a higher level. That's how I like to think about higher order functions. They hide lower level details and they allow me to change those details from a higher level. And here we're simply passing in a different function to configure the inner implementation. Another way to create a higher order function is by returning another function from your function. So we've seen this sort of thing when wrapping impurities in Section 1. Up top we have a getter function. Note the call to isObject isn't part of vanilla JavaScript. You can make it very easily though. Here we have an outer function called getter taking an argument prop, which should be a key name. And then it returns a function we can later call with an object, obj, to get back the value for the property that variable prop was set as. Or if obj is not an object, we get undefined. So it has a little safety feature. Here we set up a few different getters. Notice how much cleaner this looks than rewriting the isObject check and the turning operator to pass obj prop or undefined over and over. It's even a mouthful to say. So it's less code and it's also more expressive. And this is why writing generic functions can be so powerful. If we were hard coding separate implementations of getters for name, score, and age separately, then we will have a lot more code duplication, a lot more to read and understand. Here's an object we can use to read properties from, and we're calling the name getter with P1 and getting back the string Sandra. The score getter returns 1024, and the age getter returns undefined in the second case. We're calling the name getter with P1 and getting back the string Sandra. The score getter returns 1024, and the age getter returns undefined in both cases because P1 has no age property and the number 100 fails the isObject check inside the getter function. Let's talk about closures. So every time we call a function, a new scope is created. Even lambda functions and anonymous functions create a new scope when ran. Lambda functions just don't have their own this keyword. They inherit it from the context of the scope they're defined in. So we don't care much about the keyword this in functional programming anyway. What we do care about is that we're able to hold values inside a closure. It's very powerful. Here we have the global scope. Every JavaScript program has a single wrapping scope context created when the script first runs. We can define a variable A as 20 in the global scope. We can define a variable B as 12. We can create a new function called HigherOrder, and we could call that function and set its return to a variable named C. So when HigherOrder runs, a new scope is created. This scope is temporary. In most situations, when a function finishes running, its temporary scope is destroyed. We can declare variables inside HigherOrder, like d equals 30. We can see anything in the global scope from the scope of our HigherOrder function, and even though the global scope can't see and hear directly, at least not at this time, we can create functions inside this temporary scope like the one called inner. But unless we make a reference to inner from outside of the temporary scope, it's going to be garbage collected when HigherOrder completes and the temporary scope closes. To prevent this, we return a reference to the inner function. We don't run the inner function, we just pass it out from HigherOrder and it gets assigned to the global variable C. Now this is the cool part. Since the global variable C is assigned to the inner function, the JavaScript engine won't destroy the temporary scope created when we ran the HigherOrder function because it can't destroy that scope without destroying everything declared inside it, the inner function included. Now, if we ever decide to call the inner function from the global scope using the identifier C, another temporary scope opens up, but not directly attached to the global scope, but rather inside the temporary scope created when we first called HigherOrder. We can assign variables in this new scope. We can see variables in the global scope, and most importantly, we can interact with variables in the scope created when HigherOrder first ran, and this is what's referred to as a closure scope. There's no way to get into that closure scope except through this inner function. When the inner function returns, we lose the temporary scope it ran in. But the closure scope, the one created when we ran HigherOrder, remains forever, or until the C variable is destroyed and there's no more references from the global scope into HigherOrder. I like to think of closures as an elevator. When the elevator door closes, any people inside are removed. We don't see them again next time the door opens. But if someone in the lobby reaches their hand into the elevator before the door closes, the elevator can't depart. As long as that pointer, the arm, is reaching into the elevator, the door stays open, and we can interact back and forth with anyone inside. They're not going anywhere. And just like the elevator door, as soon as the scope can close, it will, and then it's gone. So let's write a configurable higher-order function that takes advantage of closures. So here on the screen, we have a few things. First, we have a remote logger class. The remote logger doesn't actually remote log anything, but it's something you might see in a production project. We can create a new remote logger by calling new remote logger and log a message by using send message. The message could be anything at all, and we can even include some object with that. So let's put a debugger statement in, run this real quick, just so we can see over on the left we have RL, the remote logger. You can see the prototype has send message. If we go to the console, we can see that it remote logged the timestamp, our message, and our object. So let's get rid of that. And below that, you see we have a mapping of colors, and these on the left are basically CSS styles, and on the right these are colors that would work on a terminal such as Bash. So they should work in most Linux distributions, probably iOS. Why do we have both of those? Well, like I said, we are going to create a configurable logger, and we're going to do that by using higher order functions. Okay, so at the bottom of this page, I'm going to paste in a logging function, and basically this is a function with tons of arguments that logs out a message and does so in color. The problem with it is every time you log a message, you have to pass all these arguments to it. So we could call logger, set it up with true, saying we want to use CSS. The logger object could be the console, the method. Let's get some space down here. The method could be log, or it could be info or debug. For the color, we'll put blue. The message can be anything, and the value could be anything as well. If we run this, and then we look on the left, we get a message that would be blue had we logged it out in the browser. But since we didn't, it's not. We can switch this use CSS flag to false, and then if we run it again, now we are going to get a blue message over on the left in the console. Like I said, we're passing in a lot of arguments here, so you wouldn't really want to rewrite this every single time you had to log a message. So what we could do is make this a higher order function that returns configurable functions every time we pass in some arguments. And I'd like to note that this might get a little messy. However, in the next section, we'll be learning some utilities that can do this sort of thing we're going to do now without having to nest functions. But either way, it creates closures and it'll look the same in the console. So let's make this function a little bit more configurable. So the first thing we're going to do is get rid of some of these arguments, and also this function is impure because it's reaching outside of itself to grab styles. So we will make styles an explicit argument into the function. The use CSS flag, we'll give it a default of true, and what we're going to do is we're going to return a function. We'll call it config logger, and then we're going to take all this code here and just move it up inside of that function. So now this is a higher order function. It's a function returning another function. But we're not done. So now we need to configure the logger. The way we would do that is passing in the logger object, the log method, which we could give a default of log, because normally that's what you'd be using. Now we can take this a step further. We could return yet another function from here, and we'll call this logger color. It'll take the color for the logger as well, just the color. So it'll take the color for the logger, and now let's move all this code up here. So now we have a function, returning a function, returning a function. So now this call to logger down here would look more like this. We would pass in styles, and if we were going to use CSS, so we wouldn't have to pass in a flag for use CSS, that's one call. It would return a function, we would call it again, pass in the console. Since we're using the log method, we don't need to pass that in. We call it, it returns another function, we'd have to call that, we give it our color, and then it will have to return to us another function, which we haven't yet made. Put it right here, return function, and this function will just take the message and the value. And we can give the value a default of null. Again, we're going to move the code from here up into here. And let's see what happens. We get our message over on the left. And again, it is the browser one, so we would have to pass in false to the first call to the logger. Okay, so this might look a little bit funny, and it does the same thing I was doing before, but now it's more configurable, and we can configure it partially. Like, we don't have to configure the whole thing in one go. So if we had half of it configured, we could pass that to other parts of our program. Actually, why don't we put the message up here, and the last part of this will simply be the value being passed into the logger. So now we could create a base logger, and the base logger would call logger, pass in styles, that initial configuration, and then somewhere else in the program base logger might be called, and console could be passed in, but also we might want to pass in the remote logger, and that has the send message method, and we could call this remote log. So now we have two different loggers set up, and another part of the program could go further and make a info log, and that could take the console log and basically give it a green color and a label for info. Could make a warning log, and the warning log could do the same thing except for yellow. Call that warning. And we could make an error logger. It would be red. And we're not having to pass in all of the initial configuration each time we want to set these up, and now they're reusable. So we could say info log, pass in some value, it doesn't matter what it is. Could call warning log, maybe there was a warning message. And we could call the error log, and that could pass in some error message. And now if we run this and we look over on the right, we have a green, a yellow, and a red message being logged out, and we configured those without having to pass in 100 arguments to our original configuration function. And granted, you probably don't want to be writing functions that return functions that return another function that return another function, but we'll actually be looking at utilities that will do things like this for us, allow us to partially configure or partially apply arguments to our functions, so you won't have to write large functions like this. We could actually create utilities that would create this for us. It's good to note that the closures we were talking about earlier, it's important to note that each one of these functions, when returned, creates a closure. So if we put a debugger statement in here and we run the script over in the debugger, you can see we have a closure, and the closure has access to this logger and the log method. So every time the base logger or the console log gets called, it has access to those closure methods.